Assalamu alaikum everyone, welcome back to mathematics, and we are doing A levels CI's paper Pure Maths 3, paper code 9709, variant 32 May June 2025. So let's do question number 9, that is related to topic vectors. With respect to the origin O, the points A, B and C have position vectors given by OA, OB and OC. Okay, find a vector equation for the line through A and B. So we have to write the vector form of the equation for the line AB. So let's begin with this. First of all, what is the standard form of a vector form of an equation of a line? So vector form is of equation of a line is given by R is equals to A plus lambda m, where A represents your point, any point that lies on your line, and m represents your direction vector. A is any point on line, and m is direction vector. Okay, so now for the point, we can take any point on the line AB, because for example, if this is your line AB, this is the point that lies, this is the A point that lies on the line, and this is the point B that lies on the line. So we can use either, actually the position vector is also representing the coordinates of point A. So 1, -4 and 2 are actually the coordinates of point A, that is represented as a position vector also in the vector column vector form, and point B has coordinates -2, 1 and 3. Okay, so now you can either use point A or point B because both lie on the line AB. So let's write it down. R will be equals to, I am taking point A and we are writing that in the vector form. So 1 -4, 2 plus lambda m. First we need to find the m. M is the direction vector, so that means m will be actually the vector AB, because we know these points. And how can we write the vector OAB? AB is actually, in terms of position vector, is OB minus OA. So what is OB? OB is -2, 1, 3, and OA is 1 -4, 2. So subtracting them will give you 2 -2 - 1 is -3, 1 + 4 is 5, and 3 - 2 is 1. So let's substitute this in your vector equation. So it will give you R to be equals to 1 -4, 2 plus lambda -3, 5 and 1. So this is your vector equation. Using now part B, using a scalar product, find the exact value of cos BAC. So for part B, let's first understand how these points are located. So we have already figured out, somehow assume that your AB points are like this, and your point C will be somewhere here, for example. So you need, this was your point A, this is your point B, and now this is C. So what we need is BAC angle. So let's call it to be theta. Now one thing that is a very important thing is you can apply dot product formula A dot B to be equals to A modulus B modulus cos of theta only in case when either they are both going away from a point or either they both are coming back to a point, means either they are both converging or diverging. So let's take this symmetry of moving away from point A means the direction of your AB is from A to B. So you are taking AB vector, and the direction of A to C is away from it. So you are taking position vector, the vector AC. So it will turn out to be AB modulus AC cos of theta. Now let's understand, we have already AB vector, we found this. Now we also have to find AC, so let's find it somewhere here. AC will be OC minus OA. OC is given to be 235 minus OA is given to be 1 minus 4 and 2. Subtracting them will give you 1. 3 plus 4 is 7 and 5 minus 2 is 3. So let's take this AB dot AC. AB is minus 3, 5, 1 dot 1, 7 and 3 equals AB will be square root of minus 3 square, 5 square, 1 square AC should be 1 square, 7 square, 3 square and cos of BAC. Okay, and we know that how to solve it further. We will just be multiplying, the dot product is just a product of the corresponding x and x, y and z and z. So minus 3 times 1 plus 5 times 7, 1 times 3, and now solve this. 25 plus 9 plus 1, 35, root 35 is the first one. Then the second square root is solved as 49 plus 1 plus 9. So it's 59. Cos BAC. Now solving this dot product, minus 3 plus 35 plus 3 equals root 35 root 59 cos BAC. What we need to find is the value of cos BAC, so that's pretty easy thing. We don't need to solve it further to find the angle. So this turns out to be 35 over root 35 root 59, and after solving this root 35 is actually root 35 times root 35, so it will get cancelled with 1 root 35 and we are left with just root 35. Root 35 over root 59 is equals to cos BAC, or you can write it as a single root that's it. Okay, this is all of your working for part B. What we needed to do is just to find out the angle between the two vectors. So first we have to take the vectors in the correct form. Starting from a same point means either diverging vectors and coming to a common point, that is converging to a vector. So we cannot take it as AB and CA. No, we have to take it as AB and AC or BA and CA. Okay, so the order matters here a lot. So in this way you can apply this whole formula on this and do the simplification to get the answer. Hence find the exact area of the triangle ABC. How can we find out the area of the triangle? If you can see, this becomes a triangle ABC. So if we need to find out the area of any triangle, we need we can use a sine law because it's not a right angle triangle, so we cannot use the general area of triangle formula. Rather, because we know the two sides and the included angle, like we know AB, AC and the included angle theta, which we just found to be as cos BAC. So we can use that to find out area of triangle. So let's take that. And let's take your values AB and this is AC and this is your cos BAC. So using your sine law tells us area of triangle half AB sine C, two sides and included angle. So here the two sides are half AB AC modulus, because it's about the magnitude, and sine of theta, or you can say sine of BAC. Now we already have found AB and AC magnitudes. These are root 35 and root 59. And sine of BAC, we know the cos of BAC, so we can convert that to sine of BAC by using either you can use the basic trigonometry, that would also make sense somehow, but you can also use sine of BAC to be root of 1 minus cos of BAC, cos square of, because sine square x plus cos square x is equals to 1. So we can use that formula, that is sine square theta plus cos square theta is equals to 1. So we can use sine theta to be 1 minus cos square theta under the root. So that will give you 1 minus 35 over 59 cos square, yeah. So 35 over 59 under the root. Now we have to just solve it further. Just simplify this. This becomes 59 minus 35 over 59. Then root 59 will be cancelled. 59 minus 35 is 45 and 55, so we have 24. Root 24. Now solve it further, it will become root 35 times 24, that gives you 840. So root 840 over 2. Solve it further. How can we simplify it further? If we just take out 4 out of this 840, so that it gets cancelled with this 2. So it will turn out to be 4 times 210, because we are just taking out the complete square out. So this will become 2 root 210, and that gives you root 210. So this is your whole of the working for area of the triangle. We just have used the sine law for area of triangle, half AB sine C, and the only different thing we have done here is just the use of sine square theta plus cos square theta equals to 1 to find out your sine of that angle, for which cos of that angle we have already found. So just reused it, simplified it to get your required area. I hope you understand this question of your vectors part. I have explained every bit of it. Hope it helps you. Thank you, and Allah Hafiz.